Okay, so this is the way how we will find the molecular for empirical formula. Let's discuss about empirical and the molecular formula first. Empirical formula is basically the simplest ratio of the elements which are present in the compound, and the molecular formula tells us the total number of atoms of each element. For example, if I talk about glucose, its molecular formula is C6H12. So what if it's a molecular formula? So what I'm getting from this molecular formula that there are 6 atoms of carbon in it, there are 12 atoms of hydrogen in the molecule, and there are 6 atoms of oxygen in the molecule. Beside this, the total number of atoms in this molecule are 24. 6 plus 12 plus 6. And carbon has 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. Now, after this, if you see, these are the multiples of 6. So I can simplify them by 6. So I can divide all of them by 6. 6 times 1 is 6. 6 times 2 is 12. And 6 times 1 is 6. So by simplifying it, we will get the formula, which is CH2O, having a 1 carbon, 2 hydrogen, and 1 oxygen. So this is considered as its empirical formula, because what it is telling me that how these atoms are bonded with each other, that with 1 carbon there are 2 hydrogens and 1 oxygen, that's it. But how many atoms are there in total, and how many atoms of each element are there, I'm not able to identify it by the empirical formula. It is just telling me the simplest ratio of the elements which are present, that one in a glucose, 1 carbon is present with 2 hydrogens and 1 oxygen. So that's it. So this is called empirical formula. Now when we talk about ionic compounds, so ionic compounds are always written in their simplest ratio, because ionic compounds doesn't have a molecule, instead they have a giant lattice. So if I'm writing sodium chloride, the formula NaCl, so it means that that the lattice contains equal number of sodium ions and the chloride ions. So in one lattice, there are millions of sodium ions and there are millions of chloride ions as well. So, but they have an equal number. That's why we got the formula NaCl for sodium chloride. Now, if you see over here, ammonium phosphate, there are 3 ammonium ions and 1 phosphate ion. So this is the ratio that how these ions are present in the giant lattice of ammonium phosphate. For example, you can say, let's suppose if the lattice has 10 million of phosphate ions, then that lattice exactly contains 30 millions of ammonium ion. That's why we are getting the simplest ratio of 3:1. Is this understandable to all of you? Okay. Now, covalent compounds have both molecular and empirical formulas, but ionic compounds have their simplest ratio, that's it. So see, glucose, that is the molecular formula. If I simplify it, it will become its empirical formula. Ethene, another molecule, C2H4, it can be simplified. So that yellow one is the molecular formula of ethene, and this blue one is its empirical formula. Then hydrogen peroxide, it's H2O2. So it can also be simplified to HO. But there are few covalent compounds whose molecular and empirical formula must be same, like water. I cannot simplify it further. So its empirical formula would be like this, would be the same. Ammonia, its empirical formula will be the same. Carbon dioxide, its empirical formula will also be the same. Is this understandable? Okay. Now, there are also possibility that 2 different compounds have a same empirical formula. For example, if you look at a glucose, it's C6H12O6, and ethanoic acid, it is C2H4O2. But if you simplify both of them, you will get the same formula. It's CH2O. So there is a possibility that more than one compounds have a same empirical formula. Okay. Now, here I am going to discuss the step how we can calculate the empirical formula. So what is the first step? You have to divide either the mass is given or the percentage. Whatever is given, you have to divide it by the AR. So when we divide it by the AR, what we got, we will get its moles. Is this clear? Then we compare the moles, and if we see the one which have a smallest mole, we will divide all the values with that one. So in the first step, what we are going to do, we are going to divide the mass or percentage given to us with the AR, and then the answers we got, we divide the smallest value with all the answers. See, for example, if you look at this question, xenon forms a compound that contains only xenon, oxygen, and fluorine. So you got to know that there are three elements. So you will make the ratio of these three like this. Xe is to O is to F. Now, the compound contains 22.1% oxygen. So I will going to write 22.1 over here by mass and 17.5% fluorine by mass. So in percentage, they have given me the percentage of oxygen and they have given me the percentage of fluorine. And if you see, the percentage of xenon is not, they didn't mention, and they ask you to calculate the empirical formula of this compound. So I have to first know the percentage by mass of xenon. So how could we find the percentage mass of xenon?
We
Yes.
will subtract it by 100.
Yeah, very good. Because it's a percentage. So percentage, the total of the
सर
percentage.
हम ऑक्सीजन और फ्लोरीन को प्लस करके
Yes.
माइनस कर देंगे
100 से. So see, for a mass of xenon, I will do this work. 100 minus 22.1 minus minus 22.1 minus 17.5. Can anyone tell me the answer, please?
60.4
Sorry?
सर 60.4
60.4. Okay. Just give me a minute, everyone. Assalamu alaikum. Okay, so we got the percentage by mass of xenon, which is 60.4. Now what I have to do, the first step says that we have to divide these values with their AR. So have a look at the periodic table. AR of fluorine is 19, AR of oxygen is 16, 19, and xenon is, here it's xenon, 131. So divided by 131, divided by 16, and divided by 19. Yes, tell me the answers, please. Zero.
सर
Zero
xenon का
point-
0.46 सर
1.38.
1.38.
9.21. 0.92.
0.921
0.92. So we got the three values. Is this understandable? Now, if you see which one is the smallest one,
सर 0.46
0.46. So in the next step, I will divide these by 0.46. Now for xenon, I am going to get 1. For
सर
oxygen,
ऑक्सीजन का 3 आ रहा है
3. For fluorine, is it 2?
Yes.
So the formula becomes, there are 1 xenon, there are 3 oxygens, and there will be 2 fluorine. So this is the empirical formula. So see how we will calculate the empirical formula. Did you guys understand?
यस सर
Yes, sir.
Okay. Now this question number 6 is for you guys. Do it and WhatsApp me as soon as possible. Yes. कोई प्रॉब्लम हो रही है? सिग्नल्स इतना सही है? Okay. Now, after this, we have to find the molecular formula. So I hope everyone understand how to find the empirical formula. If anyone of you has any confusion, please ask. Clear? Okay. Now, when you have to calculate the molecular formula, you have to first see that you have to first calculate the empirical formula. If the empirical formula is given, that's fine. And if not, you have to calculate the empirical formula by the same way as we did. Then you have to find the value of n. So what is the value of n? It is find by, it's basically a some whole number, which is identified by dividing the MR value with the empirical formula mass. So you guys know how to calculate the MR. So which formula is this? It's an empirical formula. So if we calculate its mass
Yes, sir.
as we calculating the MR previously, so that is called empirical formula mass. Okay. For example, see, it's H2O2. If I ask you to calculate its MR, so its MR would be 2 times 1 plus
18.
times 16. So it will
Charge.
be 34,
34.
right? That is
Yes,
its
sir.
MR. So if I simplify it, it will become HO. So HO is not a molecular formula, it's a empirical formula. So if I calculate its mass as we did for MR, like 1 plus 16, so I'm going to get 17. So it is called empirical formula mass. Is this clear? Yes.
Yes, sir.
Okay. So when we divide the MR with the empirical formula mass, we got that n, which is the whole number. Now we will multiply that n with the number of with the subscripts of the empirical formula to get the molecular formula. See how, for example, if you see over here that the compound X contains 85% carbon by mass and 14.3% hydrogen by mass. Calculate using the percentage composition data the empirical formula of X. The MR of compound X is 42. You are always late. See the time. It's 30 minutes. 4:27. So its MR is 42. Now, see, first we will calculate the empirical formula. How many elements are there in the compound? 2, carbon and hydrogen, right? So 85.7% is carbon and 14.3% is hydrogen. So the AR of carbon is 12 and the AR of hydrogen is 1. So I will divide 85.7 by 12 and 14.3 by 1. So here I will get 14.3. Can anyone divide and tell me the answer, please?
7.14.
7.1.
7.1. So the smallest figure is 7.1 here. So I will divide both the values with 7.1. So here I'm going to get 1 and here I'm going to get 2, right?
2.01. Yes, sir.
2.0, so it becomes 2.
Yep.
So the empirical formula becomes CH2. Now, empirical formula mass, it's CH2, right? So how many carbons we have? 12. How many hydrogens we have? 2 hydrogen and the AR of hydrogen is 1. So the empirical formula mass becomes 14. Is this clear?
Yes.
Now,
Yes, sir.
calculate the value of N, MR divided by empirical formula mass. So MR is over here, it's 42. The empirical formula mass is 14. So are we getting 3 over here?
Yes.
See, it's 3. So to find the molecular formula, what we do, the empirical formula is CH2. We times it 3 like this. So carbon becomes 3 and hydrogen becomes 6. So our empirical formula is CH2 and our molecular formula is C3H6. Is this clear?
सर वो ये वाला पार्ट वापस एक्सप्लेन कर सकते हैं MR अपॉन EM ESM
MR is given over here, see 42, right?
G.
EFM is the mass of the empirical formula. So empirical formula is CH2. I will calculate its mass as we calculate the MR. See, there is one carbon, so it's 12. There are two hydrogens, so 2 times 1. Then we add them, we get the EFM, the empirical formula mass is 14. Is this clear?
Yes.
So then we find the value of N, which is MR divided by empirical formula mass. So MR is 42. I have put it in the numerator, and 14 I put it in the denominator. When I divide it, I will get the value of N, which is 3. Right?
Okay.
सर
Yes.
सर ये जो MR क्वेश्चन में दिया हुआ है x का, अगर ये ना दिया हो
Then we have a one formula. If it's not given, for example, so we use this formula, mole is equals to, then obviously they have given you moles, mass upon MR. So they have given you these two values, and you will make MR as a subject to find the value of MR.
Okay.
Okay. Yes, do you know how to calculate the molecular formula? No, you don't know. Yes, Rohil, did you understand? Did you understand? Okay, go on. This is the question. Now do it everyone quickly. Okay, so okay, I have received from Saad as well. Yes, Khatija, yours was right. It's correct. Okay, Mustafa. No, here there is a mistake in your formula. Saad,
Yes, sir.
why you make that 1, 1 and 1? You skipped one step. You skipped the division by the smallest value. So see, we have a carbon, we has hydrogen, and we have chlorine. So carbon is 37.8, hydrogen is 6.30, and chlorine is 55.9. So the AR of hydrogen is 12, so we divide it by 12, we divide it by 1, and we divide it with 35.5. So in this case, I'm going to get 6.30. Can anyone tell me the other two values? 3.15 and 1.57. So see, the 1.57 is the smallest one. So we'll divide all the values with 1.57. So here it would become 2. This one would become 2. And this one, it's 4. Okay. 4 and 1. So see, the empirical formula becomes C2H4Cl. So I got the empirical formula C2H4Cl. Now I have to find the N. So molecular MR, the relative molecular mass is 128. If I calculate its MR, there are 2 carbons, which is 24, 4 hydrogens, which is 4, and 1 chlorine, which is 35.5. So
60.5.
60.5.
63.5. 63.5.
63.5.
63.5. So it's around 63.5. So the value of N you will get is 2.
yes
So C2H4Cl times 2 gives you 2 times 2, 4. 4 times 2 give 8, and 1 times 2, 2. So the molecular formula would become C4H8Cl2. Is this clear?
yes sir
Okay. So you guys take the picture or the screenshot for the practice of these questions. Now we will be heading towards moles. Done. This one as well. Okay. So you have to understand what is mole. Okay. So basically, when we talk about moles, we are talking about the number of particles. You can relate it with the 1 dozen. For example, if we say 1 dozen for something, so it means there are 12 things are there, then we are using the term 1 dozen, right? So in the same way, whenever we use the term 1 mole, it means we are talking about that substance has this much quantity, that it is equals to 6.02 exponent 23 particles. It is always for the particles. And what type of particles are there? The particles can be atoms, the particles can be molecules, the particles can be ions, the particle can be electron or protons. Okay, so if I'm saying 1 mole for anything, so it means that there are this amount of that specific particles are there. Is this understandable? Okay, so if we have a 1 mole of atoms, then it means there are 6.02 exponent 23 atoms. If we have a 1 mole of molecules, then it means there are 6.02 exponent 23 molecules. And if I say 1 mole of ion, there are 6.02 exponent 23 ions. See, these are 3 different things. They are equal in a count, but it doesn't mean they have a same mass. It is same. For example, if I say 1 dozen egg, there are 12 eggs. But if I say 1 dozen chairs, there are 12 chairs. But do both have same mass? The 12 chairs have relatively very different mass than the 12 eggs, but they both are 12, right? So in the same way, if I have this much amount of atoms, if I have this much amount of molecules, and if I have this much amount of ions, it doesn't mean that their masses are same. They are same in quantity, in numbers, basically, but they are not same in mass. Is this understandable? If anyone...
Yes, sir.
Yes.
Okay. Now, then the question arises that if their masses are not equal, then what would be the mass of 1 mole? So the rule is this: if the mass of 1 mole is exactly equal to the AR or MR of that substance, but in grams. See, whenever we are using the AR or MR initially, in the previous all the questions, we didn't mention any unit because we were saying that it is the relative mass, so it has a no unit. But when I put the gram with that mass, then it would become it's 1 mole. For example, see, this is the 1 molecule, right? What is its mass? 128. That's what you calculate. So I would not mention any unit with this 128. Then it means that I have only 1 molecule of this compound C4H8Cl2. But if I put grams with it, now it's not 1 molecule. Basically, if I'm putting gram, then it means that it would become 1 mole of this compound C4H8Cl2. And if it's a 1 mole, then how many molecules are there? Then it means that there must be 6.02 exponent 23 molecules. Now it's not a single molecule. Is this understandable? If I'm not putting any unit with it, then it's the mass of only a 1 molecule. But if I put a unit gram with it, then it means it becomes a mass of 6.02 exponent 23 molecules. For example, what is the relative atomic mass or the AR of hydrogen? Yes.
1.
1.
One.
You didn't mention the unit, right? We just say 1. So it means it's the mass of 1 atom of hydrogen. But if I say, instead of 1, if I say there is a 1 gram of hydrogen, now it means it's 6.02 exponent 23 atoms of hydrogen are there, now not 1 atom. Is this understandable?
Yes.
If any one of you has any confusion in this, please ask. So see, I have mentioned few examples over here. I'm saying that Na is 23. The mass of Na is 23, which is equivalent to its AR as well. So it means it's a mass of how many atoms? 1 atom. But if I say 23 grams of sodium atoms, so now it's unit that the AR is represented with the unit gram. Now it means it becomes the mass of this much atoms of sodium. Now it's not the mass of one atom. For example, we just discussed it's 1. So it means how many atoms of hydrogen? 1. But if I'm saying 1 gram of hydrogen, now it means we are talking about this much atoms, not one atom. For example, the AR of carbon is 12. So it means it's a mass of 1 atom of carbon. But if I'm saying 12 gram carbon, then it means it's a mass of 6.02 exponent 23 atoms of carbon. Is this clear?
Yes, sir.
Yes, if
Yeah.
any of you has any confusion in this, please ask. Yes, Laiba, did you understand? Rohil? Yes, you? Manahil? You? Okay. Now, see, it's a MR of water, which is 18. So if I'm saying the mass of water is 18, then how many molecules of water are there? 1. But if I'm saying instead of 18, if I'm saying 18 gram of water, then how many molecules of water are there?
6.02 into 10 to the
6.02.
power
6.02
Very good.
multiplied
Then
by
it
10
means
raised
there are
to 14.
6.02 exponent 23 molecules of water. Okay. Now tell me, if it's an 18, then how many molecules of water are there? 1 molecule.
1.
Okay. Now 1 molecule of water. So in 1 molecule of water, how many hydrogens are here? 2 hydrogens are here. Is this understandable? Now, if I'm saying 18 grams, then how many molecules of water are there?
6.02 Avogadro number.
Right? Yeah, it's equals to Avogadro's number, 6.02 exponent 23 molecules of water. Now, let me ask you one thing. In this, how many hydrogen are there?
12.02 into 10 to the power 23.
Very good. It means if I'm talking about this much molecules and I have to find the hydrogen, so this figure times 2. So 12.04 exponent 23 or 2 times 6.02 exponent 23. Is this understandable to all of you? So look at these examples. And if I have to find the oxygen atoms in 1 mole of water, so it is going to equal to 6.02 exponent 23 because 1 molecule has a 1 oxygen. So if 6.02 exponent 23 molecules are there, then the oxygen would also be 6.02 exponent 23. Okay. Now, see, if I have to find the number of electrons in 1 mole of water, if I'm talking about 1 mole of water, it means how many molecules are there? 6.02 exponent 23. If we look at oxygen atom, oxygen atom has how many electrons? 1 atom of hydrogen has how many electrons? 1. So in H2O, in this molecule, there are 2 hydrogen atom and 1 oxygen atom. So in 1 molecule, how many electrons are there? 10. So if I have a 1 mole, then how many electrons are there? 10 times 6.02 exponent 23. Because if it's a 1 mole, so it becomes 6.02 exponent 23. And in 1 molecule, there are 10 electrons. So in 1 mole of molecules, there must be 6.02 exponent 23 electrons. Is this clear?
सर ये वाला पार्ट दोबारा समझा
Yes.
इलेक्ट्रॉन वाला
In one molecule of water, how many electrons are there?
10
10. So if I have a 1 mole of water, so if I'm talking about 1 mole, so is it 1 molecule or there are many molecules?
many molecules
How many?
6.02 and 10 to the power 23
Yeah, so it means we have a 6.02 exponent 23 molecules are there. So how many electrons are there in these number of molecules?
we will multiply
Yeah, we will simply multiply this number by 10. Is this
Okay,
clear? Okay.
yes
Now, have a look at these few questions. We calculated the MR of glucose, which is 120. Now, for example, I have to find the number of electrons in 1 mole of glucose in 1 molecule. So carbon has 6. So there are 6 carbon atoms. So 6 times 6, 36. 1 electron in each hydrogen. So 12 times 1, 12. And 8 electrons in each oxygen, so 6 times 8. So when I added them, I got to know that there are 96 electrons in one molecule of glucose. Is this understandable? Okay. Now, if I'm talking about 1 mole of glucose contains how many molecules? It's a 1 mole. So there are 6.02 exponent 23. 1 mole of glucose contains dash atoms of carbon. So in one molecule, how many atoms are there? 6. So in 1 mole, we will multiply Avogadro's number by 6. For hydrogen atoms, I will multiply 12 by Avogadro's number because there are 12 atoms in one molecule. For oxygen, again, there are 6 atoms of oxygen, so we'll multiply 6 with the Avogadro's number. Now, if I have to find the total atoms, so see, in this molecule, how many atoms are there? 24. So if I have to find the total atoms in 1 mole of glucose, so I will multiply 24 with 6.02 exponent 23. Is this understandable?
सर ये सेकंड वाला दोबारा बताना.
This one?
No, second one from the above.
You have to find the number of electrons in each atom. So carbon contains
Yes.
6 electrons. There are how many carbons?
6.
So 6 times 6 gives me the number of electrons of all the carbon atoms in a molecule. Hydrogen has 1 electron. There are 12 hydrogens. So 12 times 1 gives me the total number of electrons of hydrogen in the molecule. There are 8 electrons in oxygen atom and there are 6 oxygen atoms over here. So 6 times 8 gives me the total electrons of oxygen atoms in the molecule. Then we add them, we will get the total electrons in one molecule. Is this clear?
सर मुझे
Yes.
6 समझा दीजिएगा.
Sorry?
सर 6 वाला एक्सप्लेन कर दें वापस.
In 6, what they are asking about?
Atoms of oxygen.
So see in the formula, how many oxygen atoms are there?
6.
So if we have a 1 mole, then how many atoms of oxygen would be there? Yes, if it's a 1 mole, then there are 6.02 exponent 23 molecules. Right?
Oh, okay, sir.
So, and one molecule has 6 atoms, so we'll multiply 6 with 6.02 exponent 23. Is this clear?
जी sir.
Okay, now we have these formulas that we are going to use in the further calculation. Okay, see, if you have to find the number of moles and you have provided with the mass, so you will divide the mass with the AR or the MR of that substance, you will get the moles. If you are given with the number of particles and you have to find the moles, you will divide that number of particles with the Avogadro's number, which is 6.02 exponent 23, so you will get the moles. If you have given with the volume of a gas, you will divide that volume of a gas with the 24 decimeter cube or 24,000 centimeter cube, you will get the number of moles. It depends. For example, if the volume of gas is in centimeter cube, so we will use this figure. And if the volume of the gas given you is in decimeter cube, so we will use this figure. Okay. After this, there is one other formula, that concentration. Concentration has 2 units, either gram per decimeter cube or mole per decimeter cube. So from this, we can also able to find the moles by making the quantities as a subject. And here we have a conversion units. So I'm going to share this file with you guys as well. So we will just review the formulas in the next class and we will attempt the stoichiometry questions, how to find the moles or how to convert the moles into other quantities. That's what we will do in our next class. And next class will be probably on Tuesday, which will be might be a first of Ramzan.
Yes, sir.
So that if it's a Ramzan, then probably the class will be from 3 to 4. Yes, they are little confusing, Khatija, but when you practice it, then you will be able to understand. Okay.
Okay, sir. Sir, I have a question that how we will convert the gram dm per cube into mole per dm?
How you will convert the gram into moles? Both have a denominator same. So if it's a gram, we divide it with the AR or MR, we will get the moles.
Okay.
So same way, if I divide it with the AR or MR of the substance, then it will be turned into mole per dm cube, the gram per dm cube thing.
Okay, sir.
Okay,
Thank
so you guys just review these formulas before the next class, and please everyone bring the calculator and the periodic table with you. Okay. Okay, take care everyone. Allah Hafiz.
Allah Hafiz.
Sir,
Allah Hafiz.
Yes.
sir. Sir, hydrated compounds और aqueous solution same होते हैं?
No, hydrated compounds are solids which have a water of crystallization in them. Just review the start of the reversible reactions. I have discussed it over there, anhydrous and hydrated.
Okay, sir. And sir, what is Na?
Na is Avogadro's number. See over here. We have mentioned, see, it's means 6.02 exponent 23. Okay.
Okay, sir. Done.
Okay. Take care, everyone. Allah Hafiz.
Allah Hafiz.